Okay, so your book's directions are a little confusing. Because they say I should, in 10.2 number 1, I should look at tangent of x is -5, and I should find a solution using the inverse function.
Okay.
And then I should answer the question, is that the only solution?
Okay.
Right? Okay, so what is the inverse function for tangent of x?
Tangent inverse.
Ha! No, it's not. That's a trick question. Tangent doesn't have an inverse function.
Well, I meant the one you're supposed to use in the
Yeah, I know, and that's what the book meant too, right?
Yeah, because
So like, they had this trick built into their thing. They didn't expect you to notice the trick, they just worded it in a screwy way, right? So what you should do is hit both sides with the tangent inverse button on your calculator, basically, right?
Yeah.
Okay, what do you get, Levi?
Well, I got -78.69.
Oh, okay.
That's in degrees.
So we took tangent inverse of -5, and we found that in degree land, this is approximately what?
-78.69 degrees.
Okay, and others of you found that this was something else, presumably?
-1.37.
In radians.
Yeah, 'cause that's what the book ended up saying too.
Yeah, so I would prefer if we could work in radians all the time, but unfortunately,
I just forgot to put it.
well, the Babylonians are a bunch of asshats. So we still have degrees kicking around. I don't know why. I wish we could get rid of it, but we can't.
So do you want
Surveying or
Like the
something.
political system.
I don't care which one you use. I just want you to know that both of those are approximations. Yeah? Okay, and then you should also tell me which system you're in. And the way you tell me which system you're in is you put a little degree if you're in degrees, and you put a little nothing if you're in radians. Radians is a unitless measure. You guys all remember that? No? Okay, cool. All right. Is this the only solution?
Well,
No, because there's 78 and 1.3.
every 360 degrees is another solution.
Well, for tangent, it would be every 180 degrees.
Yeah, so hang on. I gotta go figure out about tangent again. So tangent looks like this, right?
Huh?
You guys remember where to get tangent off the unit circle?
Yeah.
The slope.
Yeah.
Sine.
Opposite over is
cosine.
opposite of
the sine over cosine.
No.
Sine squared.
Tangent is
Yeah, so
opposite over
it's-
adjacent.
It's just the slope.
Tangent's the TOA part, right? The opposite over the adjacent. It's the slope of the kind of like, if this is an angle theta, right?
Yeah.
Then the slope of this line is the tangent.
Yeah.
Or also,
Uh,
anybody that I taught trick to
Sine
want
over
to redeem
cosine.
themselves here? Where is it?
Pass.
Dang. Can you give us a hint?
Isn't it just like?
Yeah, it's called a tangent function for a reason.
Isn't it just right there, just on the outside? Chilling?
The slope of the tangent.
Yeah. Bro, like that.
This distance here is tangent to theta.
Oh, cool.
Right? Because it is this slope. Right? And this is 1 unit of run.
Seems weird.
Right? So the slope is the rise over the run.
Yeah.
Right?
So.
And so if you go one unit, then the rise is going to be the slope.
Tangent theta over 1, I see it.
You guys with me on that?
Yeah, it's right there.
Okay, so from my picture, I think, all right, I need tangent of theta is -5, right?
Yeah.
Okay, so that's going to be like down in here someplace, right?
Uh-huh.
See that? So like maybe, I suppose that'd be -1, right?
Uh-huh.
And then maybe 2, 3,
So it's
4,
not way down there.
crap. We'll call it here.
Dang. 5.
So there's your theta there, right?
Yeah.
Well, really, I suppose there's x, right?
Yeah.
Because I had a name for this already. So then the question that they're asking, is that the only angle with this property? Oh. Right? Seems like every 180 degrees this thing repeats, right?
Yeah.
You guys
Seems
see that?
like that's-
So if I'm pegging a line -5 here, I got this one and this one and this one and this one and, right?
Mhm.
Okay, so in radian land, how would I write that?
Plus pi, k pi.
Totally. Plus k pi, where k is an integer.
Yep.
Yes? No? Maybe? That kind of makes sense.
Yes.
Please note the other angles, right? Some of them are up here. Which would be if I add 1 pi, right?
Yes.
You guys with me on that?
With yeah.
If I add 2 pi, where do I get to?
That comes in close. Yes.
Back to the blue thing. If I add 3 pi, where do I get to?
Back to the orange.
Back to the orange one again. If I add no pi's, where am I?
Where you started.
At the blue thing. Cool? Questions, Steele?